based on design thinking approach. Okay. Today, in modern communication systems, antennas are used to direct radiation in particular desired area more effectively and efficiently without any loss. Okay. But in real time, engineers face some challenges because the antenna radiates powers in other directions also. Some power losses occurs also due to line of sight usage and everything. So for applications such as radar systems and satellite systems and mobile communications, we need efficient usage of input power. That means the antenna needs to convert the input power into radiation. So for this, we want to calculate beamwidth and efficiency. Based on calculation, we need some solutions based on design thinking approach. Is there any idea?
So first I need to say about design thinking. So mainly design thinking is a problem solving approach where we solve problem in 5 major steps: empathy, defining, prototyping and testing. So in the empathy part, we will first note out what are the mistakes are facing and what are the corrections to be made, and the customers errors to be get notified. In that, the main error is taken as defined part, and we give some ideas in the ideate part, and we design a physical part as a prototype. And in testing part, we would give it to the customer and get feedback, and it will be recycled in everything. So in empathy part, as per SATET, in wireless communications, the transmission of signals is very important, where the antenna should get the input and provide output in an efficient manner with much efficiency and speed. So most of the engineers faces signal losses and power source failures and direction changes in transmission of signals. So this will not be easier while we use radar systems and satellite systems to transmit signal from one place to another. So this is taken as empathy part. So we use the measurements of beamwidth calculations to rectify this error and to come up with a new idea and to upgrade it with modern technologies.
As a different part, we must measure the antenna performance. If we didn't test the antenna performance, it may waste the powers and it create the interference and do not work as expected. For that, we need a reliable and simple to test the antenna for the direct signals and how it performs. So if we that the testing part, it may create a strong communication.
So coming to the video part, we have to say two critical part of engineers are using the parameters. That is, first one is bandwidth, the second is antenna efficiency. The bandwidth is used to spread the efficiency of the parameters. First one is low efficiency, second one is high efficiency, which is used to spread the communication to the antenna efficiency, coming to the efficiency part of the antenna.
And next is a prototype. In this prototype, we can how the antenna is working and how can we measure the signals. First, we how can we see an antenna? It will be how many rotations it will be occupied. By 360-degree rotation or 180-degree rotation. By using an antenna, it will be occupying many rotations. How signal strength will occurring it, how the strength are dividing and deviated. We can how the signal we can identify the graph graphically. We can identify the polar graph. It can be very easy to identify. We can know about polar graph. And the antennas mainly used to communicate in long distance. It can use it in marine engineering area. The narrow beam it will be occurring. The signal will be the signal has been high directivity. And the widely it will occur. Wide beam it will occur. It will be low directivity. And mainly it is used as an high power case density. It will be half of 50% power consumption and -3 decibels. It will be occupied by many other areas while using. It will be very efficient to using while both height and narrow beam and wide beams. It are used in our orbiting purpose or any other marine engineering or long distance communications. It will be very efficient.
In testing, the radar system is finding the narrow beam with the targeting in an antenna, and in satellite communication, the high efficiency of power and strong signal sending to the satellite communication. While like this way, engineers are checking the performance and sending the signals like this. Then now engineers are improving, developing the shape and material of this thing.
So in conclusion, in modern wireless communication, the measurement of the beamwidth and antenna efficiency is most important one. So by design thinking approach, we measured the beamwidth and the efficiency for improving the antenna signal quality and made the antenna to radiate in particular direction. Okay. So this will be helpful for the next generation, future generation communications also. Thank you.
Thank you.
Thank you.